A single radio pulse can look like a message from deep space, especially when it carries the same, swept, fingerprint astronomers expect from signals crossing cosmic plasma. That's exactly why Perytons terrified people. They looked like real transient bursts, bright and sudden, appearing on Sirius instruments. But the case didn't end with a new cosmic object. It ended with a human building, a routine habit, and a technology so ordinary it feels embarrassing. Perytons are brief radio bursts that imitate some properties of astrophysical transients. They can show a frequency-dependent delay that resembles dispersion, the classic signature that screams, distance. The danger is obvious. If a local signal can mimic that curve, then the sky can be faked by Earth. Perytons weren't just noise, they were counterfeit evidence. At a large radio observatory like Parkes, the telescope doesn't see images. It measures faint power patterns across frequency and time. The environment is hostile. Satellites, electronics, engines, and switching power supplies can all inject radio interference. So every mystery burst has to pass a brutal test. First question: did the universe speak, or did the local world leak? Real cosmic signals can arrive, chirped, because lower frequencies are delayed more than higher ones after traveling through plasma. Some Perytons showed a sweep that looked close enough to trigger serious attention. The early reaction wasn't naive excitement, it was cautious respect for a pattern that physics predicts. That's what made the eventual solution so shocking. A genuine distant source typically appears in a way consistent with the telescope's beam pattern: one direction, one beam, a clean localization. Perytons often behave differently. They could appear as if they were detected broadly, sometimes across multiple beams, like a nearby source bleeding into the system. That's a giant clue in radio astronomy. It suggests proximity, not distance. Another red flag was timing. Perytons tended to cluster around periods when humans were active at the facility. That's not proof by itself, but it's a powerful suspicion. Cosmic events don't care about lunch breaks, work shifts, or doors opening. If a mystery tracks the rhythms of a building, the building becomes a suspect. Investigators treated Perytons like a crime scene. They compared timestamps, weather, equipment modes, receiver configurations, and site activity. They asked which local devices could emit around the relevant radio band and under what triggers. Most interference is continuous or periodic. Perytons were sudden, so they looked for a sudden action. Sudden bursts often come from switching, turning something off, opening a circuit, interrupting a process. That's when unintended emissions spike. Perytons' transient nature suggested a mechanical or electrical event with a sharp start. The mystery narrowed from unknown sky object to a specific human action. A microwave oven is a high-powered device designed to keep radiation inside a shielded box. But shielding can fail momentarily during certain actions, especially if the cycle is interrupted. If the door is opened before the cycle completes, the abrupt interruption can produce a brief radio leak. It sounds ridiculous, until you remember how sensitive a giant radio telescope is. A solution isn't real until it's repeatable. Investigators correlated event times with microwave usage and then tested the scenario under controlled conditions. Under the right conditions, the burst could be triggered. That was the turning point. The space signal was now a laboratory effect. The case shifted from speculation to demonstration. Perytons fooled people because the shape resembled dispersion, the same reasoning used to identify real astrophysical events. Pattern recognition is essential in science, but it's also a trap if you don't test alternatives. The Peryton case became a lesson in humility. You don't just interpret data. You interrogate it. Once the source was identified, observatories tightened interference protocols, stricter activity logging, better shielding audits, correlation with on-site device usage, and improved filtering pipelines. The real win wasn't, we found the culprit. The win was, we built stronger methods. A mystery turned into infrastructure. Modern radio astronomy hunts fast transients constantly, and the number of detections has exploded. That makes false positives more dangerous, not less. Perytons arrived at the perfect time to warn everyone. Local interference can imitate cosmic signatures. And if you don't guard against it, You can build an entire myth out of lunch. Fast radio bursts are now confirmed as real cosmic events, some repeating, some not, with localization to distant galaxies in multiple cases. Perytons are different, local, reproducible, and tied to site activity. But the comparison matters because early on, confusion was possible. Perytons didn't disprove FRBs, they made the standards for claiming FRBs far stricter. One telescope can be fooled. Multiple independent instruments, separated by geography, are harder to fool at the same moment. That's why networks, rapid alerts, and cross-observatory verification became essential. The Peryton story is basically the scientific method in one sentence: extraordinary patterns demand extraordinary cross-checks. Perytons were the perfect illusion, a local burst dressed up as a cosmic event. The case was solved the only way real mysteries are solved: by suspecting the obvious, testing it, and reproducing it until the mystery breaks. If one microwave can impersonate the universe, imagine what else can. Comment the most surprising, false mystery you've seen, and subscribe to World of Mysteries.